Thank you. All right, 5-5, adding and subtracting unlike fractions. And several of you already mentioned, and hopefully all of you know, unlike fractions are fractions that do not have the same denominator. And when you're adding or subtracting fractions, you have to have the same denominator. So when we get these problems, you cannot just simply add them like they are. You have to make them into like fractions. So we'll go over that process in just a moment. Here's the main note I want you to get today. So that's my asterisk, important. To add or subtract unlike fractions. I'll move in just a moment. To add or subtract unlike fractions, rename the fractions. Notice that we use the word renaming for fractions a lot. Manipulate them to have the same denominator, or rename the fractions with a common denominator. Rename those fractions with a common denominator. And what's interesting about today's lesson is we're going to look at LCD. Does anyone remember what LCD stands for? Caroline, what's LCD?
Least common denominator.
Okay, we're going to use the least common denominator, but there's actually an infinite number of ways to work these problems out. Why do you think we use LCD though? Like, there are many common denominators, but we use the least common denominator. For what reason, Marissa?
Maybe it would be the closest to accurate.
So technically, if you use any common denominator, you can get an exactly accurate answer. But why least common? Jensen?
Because then you have to do like the less math than if you had a bigger denominator.
Yes, you could use bigger denominators, but then you have to simplify more, and so, or bigger numbers, which can be a little bit stressful. And then here's my favorite sentence. Then add or subtract. And simplify. So what does it mean to simplify? Does anyone know what simplify means? I know what add and subtract means, but what does simplify mean? John?
Makes the fraction where they have nothing that can go between each other. There's no common
Factor. And do you guys remember what that means? That the numerator and denominator are, there's prime with the words relatively prime. When the numerator and denominator are relatively prime, it has been simplified as long as the numerator is not bigger than the denominator, right? Then you change it to a mixed number. So we'll go over that process. All right, so that's the key idea. Man, that's a lot. But this is, I hope, nothing new. I hope this is nothing new to you as we work these problems out. So this is kind of review. All right, let's look at example number 1. Example 1A. So here I have m equals 7/9 plus 11/12, excuse me. 7/9 plus 11/12. Now, can I just start adding the numerators together? No, because these are what kind of fractions? Unlike. So I need to make them like. And this is what I'm asking myself in all these problems. What is the LCD? What's the LCD? So least common denominator, I think you're giving me the factor, the least common factor, but I'm looking for the least common denominator. I've heard it from some. Bella? 36. That's my key number, 36. So the smallest number that 9 and 12 go into, 36. Okay? Do you remember how to find that out? 2 ways to do it. You can list out the factors, or you could do the prime factorization, the factor tree, all that. Okay. I want to change both of these fractions to have a denominator of 36. I'm already going to start writing that. So I'm going to rename those fractions. But I have to do it using mathematical properties. What should I multiply 7/9 by to get a denominator of 36? Josie?
4 over 4.
There you go. 4/4, which is a big fat 1. So what's 4/4 times 7/9? 28/36. Or 28 over 36. So I multiplied the first fraction by 4 over 4. What should I multiply the second fraction by to get a denominator of
3 over 3.
3/3? So it's 11/12 times 3/3.
33 over 3.
33/36. Or 33 over 36.
First, or should we
So,
add?
oh,
Easier.
add first.
Add first.
Then simplify. Yeah. Good. Yep. Because right now, you can add these together because now they are what kind of fractions? Like, common denominator. So what's 28 plus 31? Or 33? 61 over 36. Is that simplified form? No, because the numerator is bigger than the denominator, and it is possibly, these two numbers are possibly relatively prime, not relatively prime. Does anything go into both of them?
1.
1 goes into it. Anything else? Nope, nothing else goes into it. 61 and 36. So now I have to change it to a mixed number. And and this is where the reason why I bring it up as division is because if you're like, I don't even know what to do, it's 61 divided by 36. How many times does 36 go into 61? So you have your 36 here, and you subtract after borrowing. So I get 25. Now, you don't have to don't go into the decimal range, but this is your mixed number now. It's the whole number part 1 and 25/36. 1 and 25/36. Does anything go into 25 and 36 evenly? No. These are relatively prime. And what's my variable? Or what? M. So M equals 1 and 25/36. Okay, you guys get that? All right, let's do another one here. This time with some. Tell me if I'm right or wrong. Wasn't in the last lesson, didn't we have like 2 asterisk notes, one for adding and then one for subtracting?
Yeah.
But then today, they're already throwing me addition and subtraction problems.
It's the same. It's almost the same thing. You just have to find
Yeah, because you just have to find the left denominator and then do the thing we did yesterday.
All right, good. So we're basically doing the same thing when you subtract. All right, so you have 1/4 minus 2/3 equals A. What is the LCD of these two fractions? 12. That's the least common denominator. So that means that 12 is the smallest number that 4 and 3 fit into or divide into. All right, so I want to make both the denominators 12, and I need to remember it's subtraction. So what did I multiply 1/4 by to get a denominator of 12? So I get 3/12. And what did I multiply 2/3 by to get a denominator of 12? So I get 8/12. All right, I'm like, uh-oh. Okay, are they like fractions?
Yeah.
Yes. But it's 3 minus 8.
-5.
Oh, yeah, that's right. 3 minus 8 is -5, isn't it? And what do you do with the denominator? Keep it. Keep the same one. Do not add. Don't add denominators. Do not add or subtract denominators. Never do that. It's never a good idea. Yep.
Could it, when you put the negative sign next to the 5, could you put it next to just the fraction itself?
Okay, so here's what I get. Like 3 minus 8 is -5, and then I get this answer. But you're saying that this number is equal to this right here?
Correct.
Interesting. Okay, yep, either one is correct. I want you guys to start getting used to, if you have an answer like this, that you start writing it like that. I think you guys are ready. Can you do that?
So if you get a negative, you want to spread it aside.
Put it right next to the bar, as best you can. And if you don't, I'm not going to mark it wrong, but try to get into that habit. And then what's my answer?
A equals -5.
Oh, that was Mr. A. So like, yeah, it's a little bit above, but that's good enough. All right, negative 5/12. In fact, if you can do that pretty consistently and well, you're already getting to a part. When I was teaching Algebra 1 this today, like we gotta be able to write it either way, like this or like that, either way. And you're already getting ready for Algebra 1. Okay, but anyway, that's my answer. I'll have you practice a couple here to make sure you're getting it. So on page 246, try out number 6 on that one. Number 6 on page 236. And what I want you to do is when you are done, and your neighbor, the person at your table, and then Tristan, you can work with those two in front of you. But when your neighbor's done, check your answer with each other and see if you're right. Number 6 on page 246.
I thought you said 46.
Oh. No, not that forward. Not yet. No, not today. All right. So number 6. Technically you can, but you'd have to divide this by 2 over 2, and you'd get 2.5 over 3. So you could do that, but then you have 1 plus 2.5, and then you're starting to get a complex fraction. So, yeah, 3.5 over 3, or sorry, yeah, 3.5 over 3 is like...
1.5.
Okay.
It's the same as
So you can do it that way, but figuring out what that is difficult. But yeah, it's definitely possible. All right, what's the LCD, somebody? Jack? 6. Oh, whoa. One of them already has a denominator of 6. Great. You don't have to change it. So I'm going to leave it 5/6. But what should I change 1/3 into? 2/6. So what do I get? 2/6 plus 5/6. 7/6. Is that correct? No. What do I have to do with that? And this one, I hope you can do, Marissa. 1 1/6 equals H. That's your answer. Okay, do number 9. Oh, my, number 9. And I want to see if you guys can write it the way we just talked about with negatives. Number 9. Yes, what's the LCD? Oh, look how nice they are. Do I have to rename both of them? No, just one of them. I'm just going to leave 3/8 alone. And what's 1/2 renamed? 4/8. 3 minus 4, negative 1 over 8. And how do you want to write it?
Put the negative sign in the middle.
Yeah.
There you go. He was saying it, you were picturing it. So yeah, I think it's this right here. And that equals n, negative 1/8. Do you guys get that? Can I throw in another thing at you guys here? I want to see if you guys can handle. All right, so you guys understand that negative 1 over 8 is the same thing as negative 1/8, which is also the same thing as 1 over negative 8.
But you would prefer to
I want this is your preferred way, but this is also the same answer. This is going to be important later on, when you can make that negative go to either one and understand it. So that's for later. You guys are doing well. Okay, I wish that was it, but there's more. Yes. Yes. Yeah, wait. If you stay here within the next 20 minutes, I will throw in mixed number problems at you as well. Okay, so thank you for staying. Actually, you know what? It's kind of that. I just said a phrase that was familiar, because my wife and I, when we were traveling, when we were first married, we were traveling up to see her family, I think, or maybe somewhere else. I don't know. But we had a snowstorm, on the road, and so we had to pull off the road, and there's more that happened there, but we pulled off this really, it was not a well-run hotel, but anyway, we went there, and the ones who clean the room cleaner, what do you call it? The maid, thank you.
Nice.
The maid left a little card, and it said, "Thank you for stay."
Thank you for
stay. I was like, huh?
That's like in our vocab book. It said squatters.
Squatters.
In our vocab book, it did.
Sorry?
It said illegal squatters.
I
know. That's a saying.
I don't want to ask what that's about, but yeah, thank you for stay. She meant to say thank you for staying, but I appreciated that. No. All right, n equals 4 1/6 plus 7 11/8. 18, excuse me. You're going to do the same thing you did in the last problems. Find the LCD, which is what?
18.
It's 18. So you're looking at the fractional parts, and you're like, okay, 18. I'm going to rename these mixed numbers so that they have common denominators. So I'm going to keep it 4. And what would I rename 1/6 to? 3/18. And do I have to change anything about 7 and 11/18? No. When you're adding two positive numbers, by the way, these are the easiest ones you can get. Just add the whole number parts and then add the fractional parts. So what's 4 plus 7?
11.
And then what's 3/18 plus 11/18?
13.
14/18.
Oh. Wow.
7 last.
Which gives you 11, and 2 goes into both of those. 7/9 equals n. So n equals 11 and 7/9. Okay? So not too bad. Yes, ma'am? The problem comes when you get negatives or subtractions. So B. Yes?
Over 8, 9.
So 11 and 8/9. So you do 3 plus 11 is 14. And then 18 stays the same. So you should get 14/8. It should give you that. All right, B. B is 7 2/3 minus 9 1/12 equals y. Find out what the LCD is. So what's the LCD on this one? Oh, thank you. It's 12. It's one of the denominators, which happens. And that's good because it makes it easier. Oh. All right, so I have to rename the first mixed number into 7 and 8/12. So I want to get this into 12. Multiply this by 4 over 4, 8/12. So 8/12 minus 9 and 12. All right, before I work this out, I realize this. I have a number minus a bigger number. So what am I? It's going to be negative. So I need to subtract, but how am I going to subtract this problem here? So how am I going to do it? Am I going to do it like this? 7 minus 9 and 8/12 minus 1/12? No. I'm going to do this. 9 1/12 minus 7 8/12. Because I know my answer is going to be negative, isn't it?
That's just your problem tomorrow.
Yes. No, you can't do the regular because you're not going to get the same answer. You're going to get a different answer. But anyway, 9 1/12 minus 7 8/12. Okay? So I'm like, can I do 9 minus 7? Yeah, I could. But can I do 11/12 minus 8/12?
1, 8, 1.
So what am I going to do? Someone already said it? Borrow. So it becomes 8 and 13/12. So listen what happened. Ready, guys? I borrowed from the whole number, made it an 8. So far, so good. And then I'm going to add 1 to this fraction in the form of 12 over 12. 12 over 12.
Yeah.
And that gives me 13/12.
But wouldn't it be 13 over 24 if you're adding?
Oh no, you're not adding the denominator. Okay.
Very good. All right. So can I do 8 minus 7?
1.
Yes.
Can I do 13/12 minus 8/12?
5/12 equals y. Y equals 1 5/12. Negative.
Because remember what we did? We switched them up because we knew it was going to be negative, and that equals y, right? You know what? This is a difficult problem, isn't it? And how do you know it's going to be negative and positive? All that stuff. That gets hard, right? Okay, ready, guys? Original problem. I'm going to estimate this answer. What's 7 2/3 round to? I'm going to say 8 is a good one. What is negative 9 1/2? 9. So 8 minus 9 is going to give me what? Negative 1? Isn't that my estimate? Negative 1 5/12? What do you think?
Well, necessarily
Fits.
it rounds to a half, but also
Yeah, and they will,
7
again,
2/3 was going to add to the 7 1/2 if we actually did.
gotcha.
Real loud.
And you see how it get us even closer to that. Yes.
I don't know how you got, like, I did it a different way, and I'm not sure how you.
Did you get this? Okay, I think the way a lot of us are going to do is this way, right? We're going to do this. I'm going to erase this so I can show you. And I'll show you how the answer comes out different. All right, so you're going to do 7 minus 9 is negative 2. And then, actually, hold on. Let's do this the right way. It's 7 8/12 minus 9 1/12, right? So we all know to make it a common denominator. And then you're going to do 7 minus 9 is negative 2, right? It's negative 2. And then 8/12 minus 1/12 is 7/12. So is this the same as what we got? No. And the reason that we did not get it right is because we did this. Do you remember how I said never put the smaller number up top when you're subtracting? So never do this. Like, don't do that because you're going to get like 8 minus 9 borrow and all that stuff. Never do that. Always put the bigger number up top. And if you put the bigger number up top in this problem, what's your answer going to be? Negative, right? So you switched it around and it becomes 9 1/12 minus 7 8/12. And that one you could do after borrowing. So this is not the same answer, although they are related. Just not an easy way. Well, okay, ready? Do you guys remember this is a mixed number? So it's technically negative 2 plus 7/12. And that actually does equal negative 1 5/12. I can't see that though right away, so I don't even do it that way. So don't do it that way is what I'm saying. Do it the other way. Okay, let's do another one. 24 on page 246. They didn't have any in those exercises, so do number 24. And then I'll have you do maybe one more after that, just to make sure you're good. So I think 24 is a nice one. It gives us good practice, and hopefully it won't be too difficult. So do you see how the bigger number is subtracting a smaller number? Then just do it that way. Like you don't have to switch them around because you can do that. You'll get a positive number, positive blah. Okay, what's the LCD? 6. All right, so 6 is the LCD. So what should I rename 7 1/3 into? 7 2/6. Good. And what should I change 3 1/2 into? 3 and 3/6. Yes. All right. So can I do 7 minus 3? I could. But can I do 2/6 minus 3/6? You can, and then you're going to get a weird mixed number that you could convert, but it's really hard to do. So what are you going to do to this?
Borrow from the 7 and make it a 6, and then make it 8. 6 over 6.
Yep. Okay, ready, guys? If you're not understanding what's going on here, please look. All right, I'm going to borrow from the 7, make it a 6. And if I borrowed 1 here, I should add 1 here, right? In the form of 8. Oh, wow. In the form of 6 over 6. So what's 2/6 plus 6/6? And is this the same as the original?
Yes.
Yes, same value, different name. It's like you guys calling Mr. A. You know some people call me Mr. Alcocer?
What?
And still some people call me Dad. What? Is it the same person?
I call you Dad.
Swivl. What do we say here? it's okay. Yeah, he's okay with it.
We can just edit that.
But I can't give you an allowance. I just can't do that. All right, but do you guys see how you can rename it here and it's still the same value? Minus 3 3/6. So what's 6 minus 3? 8, 6 minus 3, 6. And what's the variable? X equals 3 and 5, 6.
I don't understand because I can't see the board. And I'm a very visual learner.
Yes, I'm super sorry about that, Bella. You go there? Okay. Can we do that as a, if you can handle it right here, okay? Yeah. So all 4 of you, I hope you guys can handle it.
Oh, Bella just did that.
Wait, you're switching?
No, I can't.
No, I think I am blocking her. I'm sorry.
Okay.
I didn't know I
I thought
was so big.
Wait, is that our last one?
Yes, yeah, let me give you your homework. Wow.
And you mean, I mean, mine is already.
13 to 31 odd, number 38, and that's pages 246 to 247.
I'm not asking this as in like a bad thing.
Uh-huh.